Okay, we just did simple limiting reactant problems. Now we're going to do a regular, or what we consider a regular limiting reactant problem. Alright, we're going to start with the equation like we always do, and we'll have to balance the equation. But there's two questions for each one of these problems. And the first question asks, if we had 100 grams of NABR, and it's reacted with 200 grams of Ag2SO4, how many grams of AgBr would be produced? Now that's a little bit different than a normal mass-mass problem, but this is a mass-mass problem because we're starting with a mass and we're ending with a mass. In the previous mass-mass problems, you saw two different types of questions. One type of question would be something like this. If I started with 100 grams of NABR and it's reacted with sufficient Ag2SO4. And when we had those kind of problems before, we just ignored the sufficient because we knew that meant we had enough. The other type of problem, and we did this in one of the first worksheets that we did, one of the first assignments, was it'd be like how many grams of Ag2SO4 would be left over if, and what we figured out was how much Ag2SO4 I should have needed and subtracted it from what I had. Well, this is similar but different. In this situation, I've given you two masses, and one of those is the right amount, and one of them you have too much of. And so here's the whole problem. Before we can actually answer question A, we actually need to answer question B. Question B asks which reactant is in excess, and how much do we have in excess in grams. All right? Well, the only way we're going to be able to answer question B is if we answer part of question A first. Because if you look at A, again, I have grams, and for the, 20th, 30th time, are grams or mass ever a good way of comparing? And you know the answer to that's no. So what we have to do is we have to turn those grams into moles. So here's our game plan. We're going to balance the equation. We always do that first. We're going to do part of question A, and the part we're going to do is we're going to turn what we have into moles. Then we're going to pause on A, go down to question B, answer that question, and then come back and finish question A. So, for question A, we're going to start out with two things. We're going to start with 100 grams of NABR and put over 1. And we're going to have 200 grams of Ag2SO4 and put that over 1. And we're going to turn both these into moles using molar mass. Alright, that means grams of NABR have to go on bottom. And that'll be 1 mole of NABR on top. Down here, we're going to have grams of Ag2SO4 on bottom and 1 mole of Ag2SO4 on top. Alright, we have to calculate the molar mass. NABR is a pretty simple one. Na, if you look on your periodic table, is 23. Bromine is 80. 23 and 80 would be 103. Silver. This one's a little bit more complicated, the silver sulfate. The silver is 108 times 2 is 216. Sulfur would be 32. Then oxygen is 16 times 4, so an additional 64. So 216, 32, and 64 comes out to exactly 312. All right, grams go away, grams go away. We have 100 divided by 103. That comes out to 0.97 moles. The 200 divided by 312 comes out to 0.64 moles. All right, at this point in question A, we're going to pause, and we're going to go down and answer question B. All right, in question B, it says which reactant is in excess. Well, when we did the simple problems, what we started with was a little chart to make things easy, and we're going to do the same thing down here. So we're going to make our chart that we've done before. And we're going to have a need and a have. This is going to be my NABR. This will be my Ag2SO4. All right, the need, if you remember, always comes from your balanced equation. And we haven't balanced the equation yet, right? So if we have two NAs on the reactant side, or product side, we need a 2 over here. That gives us 2 BRs, so we need a 2 over here. Our silvers are 2 and 2, and our SO4s are 1 and 1, so we have it balanced. So need, from our balanced equation, we need 2 moles of NABR. And from our balanced equation, we need 1 mole of Ag2SO4, because that's what it says right there. The have comes from what we just got through doing in A. we have 0.97 moles of NADR, and we have 0.64 moles of the Ag2SO4. All right, we started with a 2 to 1, because a 2 to 1 makes life pretty simple. And what this is saying is that I need twice as much NADR as I have Ag2SO4. So that means that this number right here has to be twice of this one, or we can look at it the other way. This one right here has to be half of that one. Now, that's not always going to be that easy to figure that out. All the equations won't always be 2 to 1 or 1 to 2. You're going to end up with equations sometimes that are 2 to 3, 4 to 3, 4 to 5, 5 to 3. So it won't always be that simple. I mean, right now, it's simple enough that I can go, hey, I have to have half of that, which is about 0.485 or about 0.49. Well, since it's not always going to be that simple, we have to know how to do it when it's not that simple. So I'm going to show it to you as if it wasn't that simple. So, according to this, I already know that I have way too much of the Ag2SO4 because I have to have twice as much NADR. So the answer to this question right here, right now, is Ag2SO4. But figuring out how much is where it gets a little bit complicated. So what we're going to do is we're going to figure out how much of this I should have used. So to do this, the easiest way to do this is use what we already have on here and set up a ratio. So to figure this out, we're going to call this X, and I already have a simple ratio right here. This says that I have 2 over 1 equals 0.97 over X. And what we're going to do is solve for X. Well, to solve for X, the easiest way to do that is to get everything off the bottom. So that gives me 2x equals 0.97. If we divide both sides by 2, x is equal to 0.485, or about 0.49, which is what we figured out a while ago, right? Because we knew we had to have half of that. All right, keep in mind that 0.49 is 0.49 moles. That's how many moles we should have used. But we didn't. We used 0.64. So what we have to do is take what we used and subtract what we should have used to figure out how much too much. So we're going to go with the 0.64 moles, subtract what we should have used, which is 0.49, and that gives us 0.15 moles. So we used 0.15 moles too much. Problem is, though, I didn't ask for moles. The question asks us how many grams. So we actually have to do the opposite of what we just did in question A. In question A, we went from grams to moles. Now we're going to go from moles back to grams. So this is 0.15 moles of Ag2SO4. We're going to put it over 1. On the bottom, we're going to go 1 mole of Ag2SO4. And on top, we already know the molar mass is 312 grams. So basically what we have is 0.15 times 312. So 0.15 times 312 equals 46.8. So we have too much Ag2SO4, and we have 46.8 grams too much. All right. Since we now know which one we have too much of, we go back up to the top in question 8, and we finish our question. And we have 2 places we can start, but only one of them is good. And the one we have to start with, or to finish our problem with, is this one. We can't start with the Ag2SO4 because we know we have too much. And before we use up all the Ag2SO4, we're going to run out of NADR. So what I'm going to do is I'm going to erase this piece right here, and we're going to continue our problem. All right, that is step 2 that we're on right now. So our next step would be step 3, which is a mole-to-mole ratio. So on the bottom, we're going to go moles of NADR. On top, we're going to go moles of what we're looking for, which is AgDR. And from a balanced equation, this is 2 and this is 2. Moles cross off, and honestly, we don't need the 2's at this point. My last step is always go from moles back to what I started with, and what I started with was grams, or what I asked for was grams anyway. So we're going to go with 1 mole of AgDR on bottom, grams of AgDR on top, All right, we got to find a molar mass. Well, silver is 108, bromine is 80. 80 and 108 would be 188. So now we have what we're looking for, so now it's just a matter of doing the math. So 100 divided by 103 times 188 comes out to 182.5 grams of AgBr. And that's our final answer. Now, I hesitate to do this, but I'm going to show you anyway. What happens if you cannot get question B? And I do realize question B for a lot of people is a little bit difficult. So if you can't figure out all of B, you can at least figure out part of it. And here's how you're going to do that. What we're going to do is we're going to do both these problems. So we're going to finish this one also. So my next step here would be moles of Ag2SO4. And on top would be moles of AgBr. Alright, this is 2, this is 1. And then the next step is identical to the one right above. We're going to turn this into moles. So we have, alright, we have our 1 mole of AgBr on bottom. And we already know that's 188. This is the same step as the one right above. And so we have 200 divided by 312 times 2 times 188 comes out to 241.0. Alright. So if you can't do the bottom one, you do both questions on part A. And the one that has to be correct is the lowest number. Because before we get 241 grams of AgBr, we're going to run out of NABR first. So we do both, and whatever answer is the smallest one is correct. So this one is correct. This one is actually wrong. That means that we now know that Ag2SO4 is my reactant that's in excess. And the only part we don't quite get is how much in excess. Now for me, that's a last resort. I'd rather you get all parts of this problem. But if you can't get, I mean, if this is very, very difficult and you're having a hard time with this part right here, you can at least get part of it. So hopefully that helps.